I'm going to do a short video here just addressing the communication assignment, maybe just give some help on the transformations um, elements here. So if you want to go into the 2.6 assignment, you'll see there's a point on the parent function that you need to transform, right? Of course, to solve something like that, you know that the x coordinate of any point becomes x over k plus d, and the y coordinate becomes ay plus c, right? So you can transform any point fairly easily. You just would need to recognize what's k, what's d, and all the rest of it, right? So in my situation here, you know, I can see that a is -1, so I'm going to start with just writing some of these down. A, k, d, and c. A is -1. K is 0.5, right? K is 0.5, which is the number that appears inside the log function, but not inside the innermost bracket. Now, d is the value that comes after a subtraction sign. As you can see here, it's -5, right, for me. It's x minus -5, so d is -5, and c is finally 5. This means that if we start with the point 1, 0, it has to become 1 over 0.5 plus -5, comma, -1 times 0 plus 5, right? And so just to quickly go over this one more time, this is k here, this is d, this is a, this is c, and this is x, and this is y, right? And the point that we were given was the point 1, 0, right? So we had the point 1, 0, and we're transforming it. So here, 1 over 0.5 is 2. 2 plus -5 is plus -5 is -3, which is going to be the x coordinate. Over here, I've got -1 times 0 plus 5, so 5 is the y coordinate. Now, we can demonstrate this another way, just something we can use here in terms of GeoGebra to show this one. So the original question says we have a function log bx contains the point 1, 0. So, we could make the function log 3x, for example, and that will contain the point 1, 0, because remember, every log, right, there's log 4x, there's log 2x, there's log 10x, right? Every single one of them passes through 1, 0. So, it doesn't really matter which one of these things you choose, right? Let's show how that would work here in a sec. So my function is -1 times the f times my function times 0.5 x plus 5 plus 5, right? So let's go ahead and transform it. So I'm going to go -f 0.5 x minus -5 plus 5. Okay, so there's my transformation, right? Now, according to our theory here, our 1, 0 point should be on this graph in the form of -3, 5. Well, let's test. -3, 5 is right there, right on that graph. Now, suppose I had done all these transformations here. Instead of to f, let's do them to g, right? Or let's do them to h. Or let's do them to p. And you can see that no matter which one you transform, because in all cases we're following the transformation equation, we're taking the x value, dividing it by k, adding d, we're taking the y value, multiplying by a, adding c, and we go through and can move the point. So you can see here, this is an example where I have to give the x coordinate. Well, my x coordinate is a -3, right? I'm confident in that. Now for question 2, it's another one of these true or false ones where you're meant to be tested on, do you understand the concepts of what happens when you transform an equation? So as with always, when you're looking at these ones, ask yourself, is this true? Can I draw an example of a function where this isn't true, right? Like this, for example, the location of the asymptote is x equals d. Okay, so let's go back for a sec, and we'll make a quick equation. Okay, so let's go log 10x like that, and then let's go f of x minus d. Okay, so I'm just literally going to type in f of x minus d. It says, what do you mean by d? I want a slider. Now, you can see that depending on where I move d, right, my graph, of course, is translated horizontally, right? So if I now go and type x equals d, I get a vertical line located at whatever the value of d is. So for example, right now, d is -5. I've got the graph x equals -5. Now, is that an accurate representation of this function's asymptote? Right? Let's see. Right? Is it possible for g to go past that value? Right? Seems like a perfect match for the function's asymptote, right? And if I move it, you see the function moves and the asymptote sort of moves with me, right? So this would be an example of one of those questions where, you use your reasoning, think it through. Is there a counterexample? Is there a way this could not be true? Does it have to be true all the time, right? And remember, as always with these questions, if you're confident on a couple and not confident on another couple, go over to the discussion forum and just post it, right? And just say, I think this one's true because of this. I think this one's true because of this. I'm not so sure about this one. Can you help me out with this one? Very happy to do that. Now down here, okay, what it's asking us to do is graph the equation of a log function. And I'm going to show you just a quick way of how to accomplish this effectively. Let's start with the idea we just came up with, which is that the vertical asymptote should be located at x equals d. In this particular situation, d is a -1, right? Because remember, d is the number that comes after a subtraction sign. In this case, that would be -1. I'm going to type -1 in there. You can see it draws my asymptote. Then it gives me a check mark because that is, in fact, where the asymptote for this one is going to go. Now, for the rest of this one, right, we got to go ahead and put 3 log 9 1/5. So I'm just going to make a little bit of room here. So 3 log base 9 of 1/5. Okay, and then what have we got left? X plus 1 take away 1. Okay, so x plus 1 take away 1. Now, once again, when you look through these things, this is A, this is the B, like the base. This is K, this is D, although remember it's the opposite of D, and this is C. So quickly, A is 3, K is 1/5, D is -1, C is also -1. Now, the B value, okay, the B value is not a transformation. The B value is part of the parent, right? So this is what's a bit tricky about drawing log functions, is that every parent is actually different, right? So if you have to draw a transformation with log 9 versus a transformation with log 2, those are different, right? So you have to understand that the B value that goes over here is part of the parent. It is not a transformation, which means that we need to figure out what the like the complication here is that how for like a quadratic or something, right? It's like x, y, -2, -1, 0, 1, 2, and you get 4, 1, 0, 1, 4, right? Those are that's your parent function for a quadratic, right? That's a parent function for a quadratic. When you're doing a log, every time you do a log, it's a different parent. And so it's not so easy to like memorize a table of values that will always work. So instead, I'm going to give you the table of values for log bx, and this is what you're going to do as the parent, okay? So the parent function. So this is the trick, okay? You start with 0, okay? Then you have 1 over b. Let's say, 1, b, and b squared. Okay? So, like there's some argument here. You could use more points if you needed to, but I think this should be enough basically every single time, right? So this is what we're going to do. We're going to create a parent function like this. Now, of course, the question is, why are you picking 1 over b, 1, b, and b squared as your values? And the reason why is because when we go to actually solve these values, right? So let's start with log b0. That's going to give us an error, right? Go ahead on your calculator, try log 0. You're going to get an error. Right? So what do we know an error means? It means undefined. Basically, this is where your vertical asymptote is going to be. Okay, so your vertical asymptote is going to go with that 0. Now what about this one, 1 over b? So what if we did log base b of 1 over b? What would that be? Like, what would the answer be? Remember, the idea with log is you have to ask yourself, how many times would I have to raise b to a certain exponent in order to get this power? So for example, let's try an example. Let's say log 6 of 1/6. We get -1. Log 10 of 1/10, -1. Log 2 of 1/2, -1. What's the idea here? Is that the log of the reciprocal of the base is going to be -1, because simply b to the -1 equals 1 over b. So log looks at this question and goes, okay, if 1 over b is your answer and b is your base, what's the exponent that I would need in order to give that result, right? And the answer is, of course, -1. Okay, how about 1? What is the log base b of 1? Well, every single time that is always going to be 0, because remember, any base to the power of 0 is 1 no matter what, right? So that one's that. Log base b of b is, of course, 1, and log base b squared of b squared, log base b of b squared is 2. So this table here is how you're going to transform everything to do with log functions, okay? And it's pretty easy once you sort of just realize that every log function is just going to be the same setup as this one, right? So when we go over to create the new function, or let's create ours for log base 9. Okay, so that's our question, right? Log base 9. So here's x, here's y, 0, 1 over 9, 1, 9, and 81 are going to be my x values. My y values are VA, -1, 0, 1, 2. Now what I'm being asked to do in this question, remember, so let's just quickly show what I was just doing, okay? So here's x equals 0 is my vertical asymptote, right? Then I had 1/9, comma, -1. Then I had 1, 0. Then I had 9, 1, and then I had 81, 2. Okay, and those were the points that went on that function. Now, if I type log base 9 of x, notice that it's a perfect match, right, for all those points. So those points that we just created, including the asymptote, all fit that fit that parent function perfectly. Okay. So now we go back and we use these transformations to go ahead and transform the thing. So let's go back. Every x value becomes x over k plus d. Now in our case, what is that actually doing? Okay, in our case, well, if k is 1/5, x over 1/5 is the same thing as 5x, right? If we divide something by a fifth, you're multiplying it by 5. So we need to go 5x take away 1 is basically what we're doing. Sorry, that looks terrible. Let me just quickly erase that. So we have x over k plus d, and this is what it would equal, right? 5x minus 1. Now let's look at our x values and do that. 5 times 0 take away 1, -1. 5 times 1/9 is 5/9. Take away 1 is -4/9. 1 times 5 is 5. Take away 1 is 4. 5 times 9 is 45. Take away 1 is 44. And 81 times 5 is 405. Take away 1 is 404. Okay, and those are our x values that we're going to need in order to make the transformation. Now, of course, as you can see, these numbers can get very large very fast. So it's not common that we're going to need to go all the way to the b squared one. You could stop at just the regular b typically, right? But I mean, I'm just showing how you could get more points if you needed them. Now for all the y coordinates, okay, we have to take all the y coordinates. Y becomes ay plus c. In our scenario, that means y becomes 3y take away 1. So basically, we're going to look at y, we're going to triple it, and take away 1. Well, if y was undefined before, tripling it is still undefined, and taking away 1 is still undefined. Right? You can't do anything to an undefined number. You can't add to it or subtract from it. It's still undefined. Now, with -1, well, that's pretty easy. We're going to triple it to get -3. Take away 1 is -4. Okay, then we go on to the 0. 3 times 0 is 0. Take away 1 is -1. 3 times 1 is 3. Take away 1 is 2. And 3 times 2 is 6. Take away 1 is 5. Okay, so my theory is, if I go back to my question now, let's go back to my actual quiz. And what the quiz is asking me to do is plug in 3 points that I know. Now you can see we actually generated 4 points. We don't need all 4. we could use any of them, right? So let's just show how this would work. So I'm just going to grab this and just move it over a little bit. Okay, so let's start with the point, I'm going to type -4/9, comma, -4. Okay, and that point, you'll notice, is recognized by the system as being right. Another point we could use is 4, -1. That point is right. Then we can go to 44, 2, and that point is right. And now I've got the graph drawn correctly. Now notice I could also change this last one to 404 and 5, and it doesn't change anything. It's still correct because it's just another point that's on that graph. Okay, let's show the graph one more time over here. So I'm going to say x equals -1. That's going to be my vertical asymptote. Okay, so let's maybe take this for a sec. We'll just make it red, and we'll put a little dashed line there. Okay, so there's my asymptote. Now I'm saying -4/9, comma, -4 is 1 point. 4, -1 is another point. 44, 2, and 404, 5. Okay, so I'm suggesting, let's just hide the original for a sec. Okay, I'm suggesting that the function I'm about to draw has to go through all of these points, right? Because we transformed it in order to sort of compress it and shift it and all the rest of that stuff, right? So, okay, so let's type it in. So 3f 1/5 x plus 1 take away 1. Okay, that was the question we were given, right? 3 log 9 1/5 x plus 1 minus 1. And indeed, we have a 100% perfect match, right? Even our point over here at 404, 5 is perfect, right? Because we knew that's where it had to be based on the transformations. So when you go to do this question, make the parent first. Remember, you can use this right here to make the parent equation, right? This is how to do that. Find your a, k, d, and c values, and then transform them, okay? And that's what you're looking for there. Now the last question is a little bit more of a thinking one. It's supposed to, so what you do here is you go lock it in, and then it gives you, it says one of the graphs below is log x. Each of the other graphs has been modified by only one transformation. So either a, k, d, or c. State the equation for each. Okay, so what you're going to need to do here is you're going to need to figure out, you know, which one of these is the regular log x, first of all, and how could we know that? And then what would we do from there? So just to help you get started, the regular log 10x, let's just go back and look at regular log 10x for a sec. Okay, what are some things to notice about this? It goes through 1, 0, it goes through 10, 1, right? So when I go back to look at, you know, this chart in the assignment, like, okay, I'm going to need to look for which graph goes through 10, 1. Well, here's 10, and here's 1, so I notice that at 10, 1, the red graph goes through it. Orange graph misses it. Obviously, all the other ones miss it by quite a bit. I go back over here and look at the red. Red goes through 1, 0. Okay? Conclusion, red has to be log x, right? And now I've got that right. Now that I know that red is log x, I could ask myself, okay, which one has been moved up? Which one has been moved right or left? Which one has been stretched vertically? And which one has been stretched horizontally, right? And I can try and figure out what the rest of them are. Okay, I'll leave it for you to figure that out to make sure you understand it. But this is a question where, quite honestly, I could see the exact same question showing up on the test. Like, I put it on the assignment, right? But I could see the exact same question on the test because I think it really is a great question, right? So this is a good one to practice. Okay, so hopefully this little video gave you some insight here and some help in terms of how to approach assignment number 2.6.